So big data in oncology. So first question is, what is big data in oncology? Correct? And the answer to that question, it depends who you ask. If you ask hospital administration, it's a little bit different. If you ask medical oncology community, it's different. If you ask surgeons, it's different. If you ask radiation oncologists, it's different. If you ask pathologists, radiologists, it's all different, correct? So what is big data? And what we realize that all of this specialty has their own data set, but they don't talk with each other. Even though simple example is smoking status, they all can collect smoking status, but what are the definition of smoking status? What are the details of that smoking status? We don't know, and that's why we are not able to use this data set. So at our institution, we try to address this problem by creating one large data model, so we have a good data definition and answer that question. Now the second question comes again, what are the data domains in oncology where you collect this big data? We don't want to start from scratch. What are the data models already out there? So that's where we started. We look at NACER tumor registry data model. We look at AACR Genie Prism data model by Debtrack, Ivalapisto. And then we look at ASCO MCODE data model. So we really look at all these data models. We took at all the data elements and data definition on them, and we build our master data set. Then we realized that, okay, this is either too specific or it's too broad. So we need to do more. So we went to all our tumor type and all our doctors, because for breast cancer, ERPR and HER2 status is important. Well, that is not important for prostate cancer. For prostate cancer, they want to know Gleason score, PSA. So that's how we work with each and every expertise to build this master data model. Then question comes is that how do you store this data? How do you make sure it's secure data set? How do you make that data set is accessible to all these people, correct? So then we work with our digits team or bioinformatics team to build a large platform, cloud-based platform where we store this data. We build Tableau dashboards so clinicians can interact with data set and they can create their own data set, whatever. Radiation oncologists will be interested in specific things, so they can click and adjust the data set and build the data set like that. So that's what we did. Then next question comes how do we make sure this is a good quality data? So we build a lot of QA models, to make sure there are it's a good quality data. And then the last question comes that how can we use recent technology to collect this data? We are right now putting a lot of manual efforts. We have a team of curators in India whose full-time job is just to build structured data into the chart as well as non-structured data. Non-structured data takes a lot more time. So goal would be that we are building this robust well qualitative real world outcomes data set which will help train this AI/ML model, and in future will decrease the manual effort and will able to use machine learning model to read the notes and collect non-structured data into structured data.